Hello again. Let's pick back up and look at this example. Again, we have the 4y to the 1/5 parentheses cubed, and on the bottom, we're raising the whole thing, 2y, the whole entity to the -5 power. Now, I skipped a few steps. Let me unskip them. Let me fill them in. So we have the numerator 4y raised to the power 1/5, and we're cubing that. Now what we want to do, guys, is quite simple. We want to bring the 2y up. Now the thing is, this is a mess. Let me scroll down. We want to bring that 2y to the -5 up here as 2y to the +5. And notice when you do that, there's no more denominator left except an understood 1. So we don't even really have a denominator. 1's on the bottom, but we don't care about that. So we just have this times this. Now, if you cube all this stuff right here, you get 64y to the power of 3/5. And then times, and now if you raise to the 5th power, this stuff right here, well, 2 to the 5th power is 32. Now, y to the 5th power is evidently just y to the 5th power. So, y to the 5th power. And then, so now you got 64 times 32. Now, guys, let's get rid of this. Let's just go ahead and do that. 64 times 32, just put it in your calculator. You will get, let's see, 1024, 2048, 2048, memorizing my powers of 2 there. Yeah. And then by the law of exponents, you add 3/5 to 5. And then, this is messy. Let me scoot this down a line here. And it takes it a minute. It's a little slow about doing that. But there it is. So we got, now, so let's just go ahead. We already did this. This is 2048 here. Now remember, 3/5 plus 5, you turn 5 into 25/5. And 3/5 plus 25/5 is 28/5. That's this guy right here. And there it is. And this is actually kind of redundant now. So we can get rid of that. So that's just 2048 times y to the 28/5. So, and we're done. Later on we'll turn these into radical form and all that, but we won't deal with that right now. Again, now in the previous video and in all the videos I've done, unless I say otherwise, we're assuming that all variables are positive. Let me just get that out of the way now. I didn't talk much about that on the last video, but it was true. We were assuming in the backdrop that all variables are positive, and we're going to do that on this video as well. Okay, let's go and look at this one. Same numerator over. Now this is different. We're not raising 2 to the -5 power. It's just the y only. So that 2 stays down there as 1/2, and the y comes up. So what's going on this time is copy and paste wouldn't really be as good in a certain. What's going on this time is the 2 stays down, and give me just a second to write all this out. It won't take long at all if I do it right. So there's that. And then that y to the 5th is going to come up multiplicatively. The y to the -5 comes up as y to the +5, and it multiplies the original numerator right here. Remember, guys, we want exponents to be positive. So there's that. Notice, unlike the previous example, when we had parentheses on the bottom, this time the 2 does not come up. Because parentheses were around the 2y. Here, we were raising the whole thing to the -5 power. Down here, it's just the y only. And then, now the 2 stays down. That's understood multiplier of 1/2. So we have 1/2 times. We go ahead and cube the 4. We cube the y to the 1/5, which is y to the 3/5. So a bunch of steps got skipped there, sort of. So let's just go ahead and, so there's our 2. Now, so again, yeah, it's 4 cubed. We know y to the 3/5, like that. So, and then, but don't forget, we've got a new guy in town, times y to the 5th power. And this is all understood to be times. 4 cubed times y to the 3/5 times y to the 5th. And then you can break that up. And then let me put this in the middle. Let's just branch that 1/2 off. So we got 1/2 times the product 4 cubed y to the 3/5 and then times that whole thing times y to the 5th. So all this is understood multiplication. Well, right here, some of it would, you can see it directly here where I have the times signs, of course. So, and you know what? You can keep this times sign here, guys, but it's silly. Let's just get rid of that. It's understood, okay? It's correct, but let's just leave it like this. So we got 1/2 times all this, but now you remember by associativity, 1/2 can already multiply 64, and you already get 32 already. So let's just turn 4 cubed into 64. That's silly. And let's just go ahead and make that, you know what? Let's just go ahead and suck that 1/2 in to multiply it by 64. We get 32. By associativity of multiplication, we can multiply 1/2 times 64 and get 32. We've seen this song and dance before. And then by the law of exponents, we can add 3/5 to 5. And we know from, that's a mess. Let me scoot that down. But we know, let me just get rid of this guy right here. That's a mess. We're done. We already know that's y to the 28/5. We just add the 3/5 and the 5. That's 5 and 3/5, but we usually like to have improper fraction more than we like mixed number. I didn't come right out and say that in the last video, but we usually like improper fraction better. There are some situations where that's not true, but unless otherwise say so, let's go improper. Now, you always want to reduce, okay? Do reduce, but just stay improper otherwise, okay? Just stay improper. Staying improper has nothing to do with reducing anyway. Okay. So there's 32y to the power of 28/5. And there's that. Now down here, I pull yet another trick. I don't cube the 4. I leave the 4 out of the cube. Now what's going to happen is this 4 is free, and this 2 is free. So 4 divided by 2 is 2. And then now here you just cube, again, now you do cube the y to the 1/5. That's y to the 3/5. And now the y to the -5 jumps up here. I did skip some steps there, but let me just show it off what I did. 4 divided by 2 is 2, and that goes up top. And then now the y to the 3/5, let's just go ahead and do that already. Now that y to the -5 comes up as y to the 5. You know what? We don't have anything left on the bottom except to understood 1, do we? So really, I'll show off what I'm doing. But we're dividing by 1. Do we really even need a fraction format here at all? No. So dividing by 1 doesn't change anything. So we just have the numerator only. Okay. And then, there we go. What I had was correct, but it's silly. So there's that. And then by associativity, you can multiply the y to the 3/5 times y to the 5th. But by the law of exponents, you have this guy right here, a single y raised to the power of the sum of the two. And you get 28/5. So you have 2y to the 28/5. I'm just wanting to show off what happens when if you don't have a guy in the parentheses, he does not get cubed. Okay, so I just want to demonstrate that. We could go on all day about this stuff, but that should get the idea across. Now let's go back to radical form. 1 over radical x, that's x to the -1/2 power. Recall, which is 1 over x to the 1/2. Now, guys, we like to rationalize the denominator. I stick a radical x or x to the 1/2 power down here, square root of x. Now, I would like this to just be x down here. So what I do is I stick another x to the 1/2 power down here, but multiplicatively that is. But if I multiply the bottom by x to the 1/2, I have to multiply the top by x to the 1/2. So if I multiply this guy by another x to the 1/2, I have to multiply this by x to the 1/2. So I have this one here and this one here that are new. Now this guy was already here from over here. Okay. But remember, x to the 1/2 times x to the 1/2, by the law of exponents, that's just, you add 1/2 plus 1/2, that's just 1, or 2/2, which is 1. And I'll insert the step that I technically skipped, but it's not a big step. Remember, a law of exponents, you just have a single listing of x and then raise to the power of the sum, 1/2 plus 1/2, like that. And then we don't change the numerator, so there's that. But then remember, 1/2 plus 1/2 is 2/2, but that reduces to 1. So it's just x to the 1, which is x itself down here, and then x to the 1/2. But remember, let's go back to radical form. X to the 1/2 is the square root of x, by definition of what it means to raise something to the 1/2 power. that just means the square root of x by definition. So we just have radical x is in square root. So square root of x over x. And there's that. Okay. The instructions for this, if you're, would be to rationalize the denominator and put everything in radical form. That would be the instructions. If that's what he or she, your teacher would tell you to do, or professor or whoever. Now, if you have 1 over x to the negative half, that's just x to the half. Now, remember, guys, what is x to the half? That's just the square root of x, if you want to put it in radical form. We won't bother doing it this time. Now, remember, 1 over radical x, that is radical x. The reciprocal of the reciprocal is the original guy himself. Like 1 over a half is 2, 1 over 1/3 is 3, so on and so forth. 1 over radical x is just radical x. Okay. Let's go down here. 1 over x to the negative 3/8, that's x to the positive 3/8. 5 over 6x to the negative 3/8. Remember, that's 5, 6. That 6 is going to have to stay down. And then, now, that x to the negative 3/8, it jumps up here with the 5 and, and becomes x to the positive 3/8. Now, you can either write it like this, or you can take the x out to the side. Or the x to the 3/8 out to the side, I should say. Anytime something's out to the side, it's understood to be multiplicatively in the numerator. Like 5, 6 of j would be 5j over 6, for example. Of course, we don't have the letter j here. I'm just being hypothetical. This x to the 3/8, the point is, it's understood to be up here with the 5, now that it's x to the positive 3/8. Back when it was negative, it was not. But we want positive powers. It's just good manners. It's just tradition. Okay. Now, 3 over radical x, that's 3/5 x to the negative half. Well, that's, I kind of took the long way to Rome here, didn't I? There's a better way to do this, but humor me for a minute. That's 3/5 times 1 over x to the half. That's 3/5 times, you remember from a minute ago, for the same reason, we stick a multiplicative x to the half down here, and we multiply the 1 upstairs by x to the half. That's just going to put an x down here and x to the half up here. That's just going to put me, remember, x to the half is the square root of x here. And so we have, but remember, when you multiply two fractions, you do top times top over bottom times bottom. That's 3 radical x over 5x. That was so not the most economical way to do that. Let me show you a much more economical way. At the time, this didn't occur to me. I so regret not doing that. I don't regret what I did there, but I wish I'd also done the economical version. Let me do the economical version, and it's probably the one your professor would most appreciate. All you do, it's actually fairly short. You just stick another multiplicative radical x down here beside the one that was already there, and you stick a radical x up here with the 3, okay? And the whole point is for these two, by associativity, these two radical x's multiply on the bottom, and you just get ordinary x. So we're assuming, as always, all variables are positive. So we just get 3 radical x over 5x, okay? Notice that's much better, and I'm sorry I didn't do it that way in the first place. I wanted to show off how everything ties together. That was the purpose of me doing this up here. I wasn't totally insane. There was a method in my madness for doing this guy right here, okay? But this guy right here, most of the time, is what you'd want to do, okay? So there's that. And in a similar fashion, I showed off more relationships here. Yeah, I just kept everything together. It's the same thing as this version, except a little different. But I didn't fragment 3/5. I just left the 3 and the 5. I left everything cogent and together. I won't bother going through this guy. I'll leave it for you to read this guy. Anyway, there's all that. Let's look at this guy. Like, we have 8x to the 2/5 over 6x to the negative 1/4. Remember, this 8 and this 6, that's 8 6. That reduces to 4/3. You go ahead and reduce that. So you have x to the 2/5. Now that x to the negative 1/4 jumps up and becomes x to the positive 1/4. And then, so remember, now you can fragment this off. That's 4/3. I do fragment it here, don't I? So it's 4/3 times x to the 2/5, and that times sign is silly. Let's just write it like that. I mean, it was correct, but let's just leave it like that. And then now by the law of exponents, that's 2/5 plus 1/4 with a single listing of x. So we have 4/3. We need common denominator. We turn 2/5 into 8/20. We do times 4 times 4. We turn 1/4 into 5/20 times 5 times 5. So we have 4/3 x to the sum of 8/20 and 5/20. So it's 4/3 x to the 13/20. Now guys, we'll stop there. If your professor ever asks for radical form, he or she will want this right here. 4/3 times the 20th root of x to the 13th power. And if you ever write this on pencil and paper, you see this times sign right here? You don't have to have this if you're on pencil and paper, but if you're in Microsoft Word, you see the problem? It's hard to, it looks like I'm raising 4/3 to the 20th power, which I'm not doing. That's why I put that times sign there, okay? If you're writing this on pencil and paper, you know, create just a little smidge of space and you won't need that times sign. You're going to be multiplying in any event. But anyway, that's just a little syntactical note for you, okay? And now here's another approach. I don't fragment. I just leave everything together. I reduce. I bring the x to the neg 1/4 up, but I just leave everything together. I still do the law of exponents, and I still get my 13/20. I didn't bother showing all the adding the fraction steps this time, but you can put those in if you want to put them in. But I do fragment at the very end, but I wait until the bitter end before I fragment. Your professor might be okay if you stop here. To me, this is a little cleaner and neater, but whichever, just make sure your professor is okay with this if you'd rather stay with this, okay? In any event, going down to this one, again, you reduce 8/6 to 4/3. You bring the negative, this time it's neg 3/4, so we bring up 3/4. And I fragment early on this one, 4/3 times this, and again, this times sign is correct, but I don't particularly, it's silly, I don't particularly need it. When they're together, it's understood to be multiplied when they're together like this. So, but by the law of exponents, you do a single heading, x to the 2/5 plus 3/4, get common denominator, add them together, you'll get x to the 23/20. Now, if you go back to radical form, notice I didn't talk about that up here. Up here, when we had 4/3 x to the 13/20, remember, that 4/3 just sticks out. Then we get the 20th root of x to the 13th power. Remember, by the very definition, x to the 13/20 is the 20th root of x to the 13th power. That's how we define the fractional exponent in the first place. And in a similar fashion, that's how we define this guy in the first place down here. Now there's a difference. Notice that 13 is smaller than 20, but here 23, the power is bigger than the radical. If the power is as big or bigger than the radical, you can do some stuff. Well, sometimes you can do a little stuff anyway. Make sure all fractions are reduced. So as long as all fractions are reduced, you can't really do anything with this guy here. Notice that if 13/20 would have been like 8/20, we'd want to reduce it down to 8/20. Like this would have been 8/20 in the end. We would have reduced it to 2/5, and we'd had the 5th root of x squared. Okay, but we didn't. That didn't happen. But I was just saying in the hypothetical if it did happen. So now down here, we have the 20th root of x to the 23. Remember, the biggest multiple of 20 that is smaller than 23 is 20 itself. So we turn this x to the 23rd into x to the 20th times x to the 3rd. That x to the 20th comes out. We do 20 divided by 20 is 1. That's x to the 1. All variables understood to be positive. And then that x cubed right here that could not come out. So we have that. So we have 4/3 x times the 20th root of x cubed. Now if you're on pencil and paper, you can delete that times sign, but since I'm in Microsoft Word, you know what? I could create a space like that, couldn't I? Maybe I'm silly. But since I've already sort of got my hand in the plow, let me just reintroduce that times sign. On pencil and paper, you can put the times sign, but you don't have to. It's just like the one I talked about a minute ago, this guy up here. But anyway, there's that. And guys, I'm out of time, and I'll see you on the next video. Thank you. Bye-bye.